Solve triangle ABC if A equals 30, B equals 20, and angle A equals 50 degrees. Okay. First thing we want to do is draw this out, see what information we have, and then based on that, we can determine what the next step will be. All right, so we got angle A here, which is 50 degrees. We have side A, which is 30, and side B here, which is 20. All right, so this is what's known as an SSA triangle, right? We have two sides. And notice that the placement of the letters is actually important, right? So we have two sides and an angle that is not in between the two sides. So for example, if this was 50 degrees, this would be an SAS triangle, right? Because the A is between the two S's, SAS, side angle side. And actually, that would be a different approach. We can't use a law of sines. But for an SSA triangle, we can use a law of sines. Okay, so we've categorized it as an SSA triangle, which tells us that we have to use law of sines. Let's just set it up, right? The sine of 50 degrees divided by its opposite side is equal to the sine of B, we'll say, divided by its opposite side is equal to the sine of C divided by its opposite side. What do we notice about this? This fraction, we actually don't know either of the two values, right? And so if you look at here, right, you can use this proportion to solve, right? But notice, what are we solving for? We're solving for angle B, right? We're actually solving for the sine of B, right? So if we cross multiply this, we get 30 times the sine of B is equal to 20 times the sine of 50. And sine of B, whatever that is, right? That's going to equal 20 times the sine of 50 degrees, all divided by 30. Notice we have to use the inverse sine function, right, in order to solve for angle B in this case, okay? So once again, don't round any intermediate steps, okay? So hit 20 times the sine of 50, divide that by 30, okay? So actually, I'll write this one out, right? Sine of B, we get something like 0.5106. Once again, don't round this number, right? Keep it in your calculator. So B is going to equal the sine inverse of this whole number. Okay, now once you do this, right, your calculator is going to tell you 30.7 degrees. Okay. Now you got to be careful with this, right? There's actually two possibilities. Whenever we're doing the inverse sine, okay, we know that B or the angle could equal 30.7, or it could equal 180 degrees minus this, okay, because sine is positive in quadrants 1 and quadrants 2. Okay, so there's actually two possibilities for angle B, okay, an acute angle or an obtuse angle. So it's possible that B could also equal 180 minus this, which is 149.3 degrees. 149.3 degrees. But you notice, well, wait a minute, if B is 149.3, this is already 50 degrees, so this actually doesn't work, right? In terms of this problem, right? In terms of this triangle. Okay, so remember, whenever you have an SSA triangle, right, and you're doing the inverse cosine, you always have to consider both possibilities. Okay, so, well, wait a minute. I know now that B is 30.7. Hey, look at that. I know these two angles, which means I can figure out what angle C is, right? C, we know that the sum of the three angles is 180, so I'll just subtract these from 180. I actually get 99.3 degrees. So there we go, right? I know that C now is 99.3 degrees. So then you set up another proportion and I solve for side C, right? So sine of 50 over 30 is equal to the sine of 99.3, because we just found that out, divided by C. So we can once again cross multiply this to find the length of side C, right? So C times the sine of 50 is equal to 30 times the sine of 99.3, and I'll divide that out. So C, whatever that is 30 times the sine of 99.3 degrees, all divided by the sine of 50 degrees. Okay, just a quick reminder, do not round any intermediate steps. Okay, just enter this in your calculator as you see it. 30 times the sine of 99.3, enter. Divide that answer by the sine of 50 degrees, right? You should get 38.6 if you round that guy, right? That's going to be side C.